Brad Williams, Frugal Finance, Future Value. What's future value all about? It is the growth of money over time based on a particular interest rate. Here, future value is the amount of money an investment will grow at some date in the future by earning interest at some compounded rate. For example, suppose you put $2,000, the present value, into an account earning an interest rate of 10% per year. The amount you'll have in 5 years, assuming you take nothing out of the account before then, is called the future value of $2,000 at an interest rate of 10% per year for 5 years. What does that mean? That means your $2,000 will earn 10%. Then that $2,000, or whatever that difference is, it looks like $2,200. That $2,200 will grow at 10%, and so on and so forth. Let's define our terms more precisely. Present value, or beginning number in your account. Here it is, $2,000 is present value. Interest rate, generally expressed in percentage rate per year. Here it is, 10%, or 0.10 as a decimal. N, number of years the investment will earn interest, and the future value, total amount at the end of N years. So let's calculate the future value in this example. First, how much will you have after the first year? You'll have your original $2,000 plus interest of $100, 10% of $2,000, or 0.1 times 2. Your future value at the end of year 1 will therefore be $2,200. That should be $200. Future value, $2,000 times 1.10 is equal to $2,200. If you redeposit this entire sum of $2,200 for another year, how much will you have at the end of year 2? During year 2, you will earn 10% interest on the entire $2,200. Interest earned is thus 0.10 $2,200. 420, you will therefore have $2,420 at the end of year 2. To gain further understanding of the nature of compound interest, we can break this future value of $2,420 into 3 components. Next, there's the interest on the principal, $200 in year 1, and another $200 in the second year. The interest on the original principal is called simple interest, $400 in our example. Finally, there's $40 of interest earned in the second year on this $200 of interest earned in the first year. Interest earned on interest already earned is compound interest. The total interest earned, $240, is the sum of the simple interest, $200, plus the compound interest, $40. Do you understand that? Just break it down. I'm not going to show you how to do that, but I want you to think through that. If you're kind of scratching your head going, compound interest and simple interest, what is $200 times 0.10? Okay. And that's going to be $20. Times 2 years is going to be $40. Particularly speaking, you do not care how much of your total interest of 420 is simple interest and how much is compound interest. All you care about is how much you're going to earn. Show me the money. All right, that's what it's all about. Show me the money. So here we can use this analogous as future value equals $2,000 times 1.10 times 1.10 equals $2,000 times 1.10 to the second power equals 2420. 3 years, $2,000 times 1.10 to the third. And you can see this chain of reasoning. And here we go. 5 years, 3,221. This is how I used to have to calculate this before Excel. That should kind of give you an idea of my age. Thus, we have our answer to the original question. The future value of $2,000 at an interest rate of 10% per year for 5 years is $3,221.02. The total interest earned over the 5 years is $1,221, which $1,000 is simple interest and $221 is compounded interest. More generally, if I is the interest rate and N is the number of years, the future value is the 1,000 given by this formula. Future value is equal to $2,000 1 plus N, I of N. Expression multiplying the present value of $2,000 is the future value of $1. Expression multiplying the present value of $2,000 is the future value of $1 and is known as the future value factor. In our example, it is 1.61051, easily found using Excel. The formula for this future value is, there's going to be some crazy stuff in the mortgage section if you elect to buy that course. And this factor, if you open up a present value, if you open up an aged finance book, and I say aged, back in anything printed in the 80s, probably early 90s. You're going to have these present value factors and future value factors at the end of the book. Is you take whatever the rate you're trying to achieve and then whatever specific formula right here, and you'll have this present value factor. I explain it in detail. So anyway, the future value of any amount invested at 10% per year for 5 years is just the amount times the same factor value. So you could take whatever amount it is, $2,000 times 1.6150, and this is for 5 years at 10%. See if it does. Nope, that's just the formula. That should calculate to 3221. Well, let's go. $2,000 times 1.61051 equals, and magic. Isn't that amazing? So then Excel stepped in and gone, well, that crap at the end of the book is exactly that crap. We're gonna put this into an Excel format so you can save yourself some time. So there you go. But what happens when Excel is hacked? Or what happens when Microsoft is shut down? I prefer the actual software on my PC. I don't want to entrust anything within Microsoft. So what happens if something breaks and you can't compute specific information and you're not aware of this present value factor because you're young and you're using black box technology, or you're using AI, or you're using these formulas, then you're going to be stuck. Familiarize yourself with this present value factor. And that is simply using these formulas to come up with this factor. If you need the annuity present value factor, use the annuity formula and it'll be in your back pocket. Calculating future values. In practice, there are a variety of ways to do this, which we can illustrate with the example, calculating the future value of $2,000. We can use this methodology, which I'm very familiar with, and you're going to see examples where I use this in substitution of Excel. Here is an Excel, it's right here, okay? The future value, this is all new to you. Click this FX, and this is how it works. You're going to have a rate. So here it is, 10%. You're going to input this. Number of periods. If you're not sure what that is, hit this box. And it's going to go NPER is the total number of payment periods in the investment. Payment periods. For doing annual compounding, it's 5. If it's semi-annual, what are you going to do? You're going to multiply that times 2. What if it's daily? Well, it'll be 5 times 365. Payment? Well, there's no payment. Present value, remember? If we go up here, we have this present value. Let's keep that in mind. Why are we putting a negative in front of that? It's because it's outflow. It's money going out to an investment. PV is the present value or the lump sum amount that a series of future payments is worth now. If omitted, PV is equal to 0. When you're working through this stuff, again, if this is all new to you, this is where practice comes into play. So just work through that. We can use a table of future value to compute the future values, as I had mentioned up here. And then if you're really stuck, it's called the Rule of 72. If you studied finance like I did a bazillion years ago, the Rule of 72 was common practice. All you do here, you take 72, what's the interest rate? 0.10. 72 divided by 0.10 is equal to 7.2. Surprisingly, it's pretty accurate. So anyway, just a quick and extended version of future value. Just for the newbies, if you're familiar with this stuff, well, move on. Brad Williams, Frugal Finance,